So we have another Game Gear here for repair. This one has a very interesting issue that I thought it was worth doing a video on. So this is from a user on Discord, and he mentioned specifically when using the Crix EverDrive that the console exhibits some weird visual sort of lines across the video. So I have my own EverDrive that I know works, I have the customer's EverDrive, I've got a generic game to test, and we're going to take a look at if we can fix this board and what's causing the kind of glitching issue. I've just opened another store locally where I live, so all of our stock is currently down there. So I have no spares whatsoever on me at the minute. I've got no ribbons, no clean screens, so if this requires actual replacement parts, we're not going to be able to fix this one today. But let's at least take a look at this and identify what the problem is. So we have the console here. So let's just first try and power this board up and see what we're dealing with. We'll check for red light boot first, which we appear to be getting to no problem. Just do that a few times. Yep, so we appear to be getting to red light boot no problem. So the user mentions they have issues with the EverDrive, but let's just first start with, do we have issues in general? So you can see there we have a game loading. So now let's just try the EverDrive. And the only real difference I can think with the EverDrive is it uses more power. So it could possibly be power related, although it's not always an indication. It could simply be coincidence, frequency of the game, the amount of RAM it uses. There's many other things that can factor. Yeah, and there you go. Let's turn this around so it's facing the right way. And you can see there a kind of glitchy screen. You can actually see there, that's now a stable screen. So notice it's related directly to the brightness wheel. So the brightness wheel will draw more power naturally for the backlight requiring more power. So this could be power related. But that is definitely, and I know this from experience, this is when you have a bad clock, almost definitely. So this is the pixel clock faulting. And it's interesting that it's happening on the scroll of the wheel. So let me just see if I can get that happen with the original game, because if it is the brightness wheel related issue, it won't necessarily have anything to do with the EverDrive. It's possibly just easier to get working on the EverDrive. Let me see if I can get this failing with an original game. So not that one specifically. It could be one that uses certain pins. So let's just try a few more, because some games don't use all the address lines, for example, and the EverDrive will definitely use all the address lines. Let's just try a few games and see if I can get this to fail. So that's not booting Sonic 2, so that's probably just dirty contacts. There we go. And now can we get Sonic to fail? No, so let's try Castle of Illusion. And Castle of Illusion is messed up in a similar way. So you see, yeah, so Castle of Illusion is actually messed up very similar, almost identical to the EverDrive. So you can see there, it's hard to see, but you can see it's related to that. It also doesn't look like it's in the right mode. So has this got the SMS pin missing? Yeah, the SMS pin isn't soldered. So let's just solder that. I can't see that being the sole cause though. I'd be quite surprised if it was. But let's fix this so it shows the Master System game correctly. So now that shows correctly, but you can still see, interestingly, Castle of Illusion has an issue with the wheel. So this isn't power related. What I was thinking was the EverDrive draws more power. Castle of Illusion is simply a Master System game. So it's in some way related to Master System games and this brightness wheel. And there's a perfect example of the bad clock. So I'm just going to do something quite simple at the minute. The fact that it's related to the brightness wheel and not power related, meaning it's not the fact that the clean screen is drawing more power that causes this to happen, I'm going to just simply cut the traces under this brightness wheel. What that will do is disconnect it from all of this circuit generating the contrast voltages for the old screen. It'll also disconnect a lot of the circuitry on the old screen coming back to all these components. And as we're using a clean screen, they aren't needed anyway. So if we take a look at the contrast wheel, you can see one trace running across and down here, this thin one, and a slightly thicker one here running across and down. So all I'm going to do is I'll just use my tweezer tip for this. I'm just going to cut those traces away so that there is no connection between the contrast wheel and the rest of the circuit. And you can see now the little trace coming out of here and going down is cut there, and this trace coming out of here and down there is cut. And go ahead and just solder the ribbon back into place now. And now let's do another test. And we can see there we still have the kind of glitchy issue, but now it's actually permanent. So the wheel now doesn't affect it, but the wheel was interfering with it. So the next thing we could do is we know it was something on this circuit. So I can go ahead and, for quickness, start removing the components of the contrast wheel circuit, which are this capacitor, resistor up here, the transistor here. They're all related to the circuit we no longer use or need. So I'll remove these probably one at a time as well, just to get a feel for what ends up being the problem if we wanted to investigate further, or in case it's a common issue that other people will start to get with a common solution. And let's also, while we're at it, let's just move this ribbon off the contrast wheel, because I know they're fragile and often end up damaging. And let's just chuck a fixed resistor on for now, so we get a backlight on the clean screen. And then we're not having to deal with anything to do with the ribbon cable going up to the backlight. And we should always see a backlight on the screen. Okay, I'm also going to probe around the board while this is all glitchy to see if we spot anything, any specific area. I'll tell you what as well, let's get the Game Gear pin, which basically Master System games, and now I'm presuming EverDrive, which we could double check as well, send the Game Gear SMS pin high or low. So without a game in, it's the 4th pin over, I believe. So 1, 2, 3, 4th pin. That's currently 5 volts. We put Castler Illusion in. Stays at 5 volts. We put a regular game in. It gets grounded. So the 4th pin here gets grounded, which is what seems to make the console boot. So if we tell it is a Game Gear game by grounding that wire, just out of curiosity, let's see what happens. Because again, what we're looking for, without trying to use the oscilloscope and just use real basic diagnostics, is I'm just looking here for what is different about a working game to a non-working game. Originally we had a working game and an EverDrive, which the only difference I was aware of is power draw. Then we found out that another Master System game has the same issue, and we also proved that by removing the contrast wheel, which also had an effect. So something about the contrast wheel circuit where it goes to, which we can investigate further in a moment, was interfering. But what's now the common thing between Castle Evolution and the EverDrive is they both act as master system games, as we've just seen. They leave the SMS pin high, and that's what's causing issues. So all I'm going to quickly try now is purposely forcing the system into constantly thinking it's a Game Gear game. So for that, I'm just going to solder on a wire to 1, 2, 3, pin 4 here, which is the master system pin. And we can just touch this on ground when it's booting, which let's find a ground close to here. So the big pad here has ground. So now if we take Castle Evolution, now let's get ready with the wire. So if this boots and goes glitchy, we can touch to ground. There we go. And look at that. Let go, problem. Touch to ground, goes away. So you can see when it is a Master System game, but you force it into Game Gear mode, it displays wrong because it reads the data wrong. But it also shows that the problem only exists when it's outputting in Master System mode. So we've now identified the actual problem. It's something related to the Master System pin, or how the system is loading Master System games. So if we try with this, you can see even on the EverDrive, you touch and let go and it goes from working to not working. So there, working, let go, and jargon. So what's interesting about the fact that it's this Game Gear pin that we found the issue on? Well, here's the contrast wheel that was having some kind of effect on the glitch. And when we moved it up and down, it affected the circuit. So it goes up to here to 34 volt, which has no effect, that isn't even connected anymore. Goes down to ground here, so that's unlikely anything. Comes out to the capacitor and Q6, which go off to another part of the system. The cap's just grounded. The Q6 goes off to a 34 volt line that doesn't go anywhere, but if any of these components had issues, they ultimately head over to the LCD, which could then short to the other pins. However, if we go backwards from the contrast wheel through R32, Q5, R31, and look at this pin connecting to R31. Goes up, across, and it's labelled GG, Game Gear. So we have the cartridge connector with the GG coming off. One goes to the ASIC, pin 66, and the other goes to R31. So we are very much likely have an issue in this backlight circuit interfering with the GG pin potentially. So a quick and easy solution to this is, because again we're not using any of that backlight circuit, is let's try and just cut the wire going from the GG pin on the cartridge connector, going left to all the backlight circuit over to R31, and let's just disconnect all of that from the circuit and first see if that has an effect. So if we flip over, it's actually inside here, the trace that will be running through here up and to R31. So actually, just for quickness and a bit of simplicity again first, let's just remove R31, and then if the issue is after R31, the problem might go away. Again, this is killing me to not use the oscilloscope to show you exactly what's going on. But I'm purposely trying to kind of work blind here and show you, one, how much more difficult it is to fix things without an oscilloscope, but also that it's still possible. You don't have to have every tool for the job if you're going to use simple techniques like cause and effect and comparing to working boards, things like that. So now that's off, we've got the EverDrive in, let's give this a go. There we go. And no, with that disconnected, we can still fix it by touching, but it hasn't solved the problem. So again, let's do another few little bits of just simply removing components I know are on the contrast circuit and they're not needed, like these caps down here. The 1 microfarad caps are not needed. Let's get rid of them. Let's give that another go. Nope. So So if we just take a look at the backlight circuit, let's see what we can remove. Starting with the things that are most likely to interfere first. So we should probably remove the R33 and 34 and 32 and Q5. So let's go ahead and remove those as well. And again, I'll do a few at a time and keep testing so we just know what the issue was. Remove them 3. And remove the top resistor. So that pretty much disconnects the entirety of the contrast wheel area at least. Still got issues there. Let's remove Q6. Give that a go. So at that point, I think I've pretty much removed everything that would affect it naturally. So we have R31 gone, which is the first connection, which in theory should disconnect all of this circuit from the GG pin. I've also, for safety, removed Q5, R32, R33, R34, C34, and Q6. So we've completely and utterly isolated the contrast wheel as well as the GG pin. All of this extra stuff here, although we could remove basically all of that, I don't think will gain us anything at that point. But it is very interesting that the brightness wheel did have some effect on the GG pin, but that could just be, it does have a connection to the GG pin originally, so it was having some kind of interference, but the problem doesn't lie there. So we've seen that the issue is related to the master system specific mode, and that when the EverDrive boots, it appears to be in a kind of master system mode when it boots up. We can see that they both visually look normal if we ground the master system pin. So what variables are we left with at the minute? We have 2 games we can get the issue with. In fact, 3 if we use my EverDrive as well. So we know the EverDrive and master system games have a familiar issue. And if we're going to try and solve this one without an oscilloscope, we are down to now, I'd say, having to swap components. So let's try and think logically what those components could be. 1, the ASIC could be dead, which we'll swap last. 2, when we're loading master system games, it uses more memory. So it could be the work RAM over here when it has to load more memory. Again, if I had an oscilloscope, I'd simply probe these lines. It could be just simply missing one of the data lines on here. A very simple fix with an oscilloscope. Could be related to this pin here on the data line. There's so many things where I would want to solve this with an oscilloscope, but the options we're left with is blindly swap ASIC, blindly swap the RAM for if it's using more RAM or has more signals going in on certain pins that are only used on master systems. We have the clean screen, which also has its own RAM and acts differently on master system games that could be messing up. Could be poor ribbons, even though they look semi-okay. And it could be, which I highly doubt now, part of the circuit here, which we could solve by removing more components. So let me know what you think I should do. Should I continue to show you how to fix this Game Gear without an oscilloscope and show you the processes I would genuinely use now if I had no choice and I was effectively lacking the right tools on how I want to solve this and go about it the way I'd do with less tools? Or do you want me to crack out the oscilloscope and show you how easy this will be to fix, presumably, when we can actually probe all the signals, check everything's running correctly, and probably solve it in a more technical manner? My obvious preference is to use the right tools to find the correct problem, and you've seen how difficult it's already been to find any information out on what could be the problem here, or inserting different games, stumbling across the fact that it seems to be master system, shorting out the master system pin to show that it does technically load games normally and it's entirely related to the master system way that the console runs, either the pin directly, which I don't think is the problem, the pin seems to be stable, but we can't see that without a scope. Or it could be other things that this board does when it's in master system mode that then interfere with the clock, which again we could see with an oscilloscope. So I'm happy to go and try and blindly fix this console, or we can jump on it and do the technical way. So let me know in the comments what you want me to do, and that's what we'll do next. Hopefully this is still useful, not always showing you the way I do it with all the tools in the world and everything I need to diagnose things, but also trying to show you guys how to diagnose things without every tool. And all I've really done here is used a soldering iron and a multimeter so far, and we have made progress and discovered the problem. Either way, I'm sure we'll get this one up and running in the next video, so let me know which way you want me to take, and we'll get on and solve this Game Gear problem.